Today we're going to talk about adding and subtracting mixed numbers. So a lot of the skills that we've been working on all wrap into today's lesson. The one thing I need to point out to you in my highlighter bubble here, you must have common denominators. Sometimes you'll get lucky and you'll already have common denominators in the original, and sometimes you'll have to take that extra step to switch them to common denominators. So I'm going to work through a series of problems, both adding and subtracting, some that are basic, some that have a few extra steps. All right, let's look at number one. If I have 7 and 4/9 plus 10 and 2/9, now I prefer to write them vertically. You could certainly write them horizontally, but I think when you write them as I have here, it's easy to add the fractions and easy to add the whole numbers. And that's exactly what we're going to do. So I do have common denominators here, which is great because I don't have that extra step. My denominator will always stay the same, and I'll add the numerators. 4 and 2 is 6, 6/9. Then I'll add the whole numbers. 7 and 10 is 17. Now this is a perfectly accurate answer, but it's not in simplest form. So we would switch it, divide by 3, to 17 and 2/3 as a final answer. This would probably receive like 1 point off. It wouldn't even be half credit, like it would only be a little tiny bit. It is important to remember we like to have something, a standard that we can all check to be sure that we're the same. Even though these two are equal, we would normally go with the simplified version. All right, let's look at an addition problem where we do not have common denominators. 6 and 1/4 plus 2 and 7/8. I also like it when I write it vertically because I can write the equivalent next to it. So the 6 will stay, the 2 will stay. I know some students don't bring the whole number over. They just work with the fraction part. I've forgotten it in the past, so I've just gotten in the habit of writing it again. It doesn't take that much extra. And if it prevents you forgetting it, it's worth it. Okay, so we need to find a common denominator that will work for 4 and 8. Now the smallest one is 8, but if you didn't see that, you could simply multiply and get 32. It's a common denominator. The numbers are bigger, but it's still a common denominator, and that's what we need. So to get from 4 to 8, I times 2. So I'll do the same thing on the top. 1 times 2 is 2. This fraction will stay the same. Now I have common denominators, and I can simply add. 2 plus 7 is 9. Keep the denominator. 6 plus 2 is 8. This cannot stay. You've got an improper fraction here. That needs to get taken care of. So this 9/8 is really worth 1 and 1/8, right? Take out 8 of the 8s. That's the 1, and then there's 1 left over for the 1/8. And we're going to add to that the 8 that we already have. So a final grand answer of 9 and 1/8. And if you've been practicing your fractions to decimals right away, your brain just went, ooh, that's 9.125. Okay, let's talk about some subtraction. This one, we will not have to regroup, but we will need to find a common denominator. So I have 8 and 5/6 minus 2 and 1/3. Again, I will write my whole numbers, set this up. I think I'm going to go for 6 for the common denominator. I could go for 12. I could go for 18. I could go for 24. Anything that is a multiple of both numbers. Our top fraction will stay the same because we didn't change the denominator. The bottom fraction, 3 times 2 gives me 6. So 1 times 2 gives me a numerator of 2. Now be careful, this is subtraction. 5 minus 2 is 3. Keep the denominator. 8 minus 2 is 6. I cannot leave it because it's able to be simplified. So 6 of 1/2. Pay attention to your signs, whether it's addition or subtraction. Now, that one we had to find common denominators, but we didn't need to regroup. I'm going to show you one problem twice. I'm going to do the same problem 2 times to show you 2 different methods. One is that you regroup. And parents, if you're listening in, we learned this as borrow. We've changed the language a little bit. Didn't change the steps, just what we called it. And the other method is going to be to switch to improper. So I'll write that when we get down to it. Our problem is 8 and 1/3 minus 2 and 1/3. Yay, we have common denominators. We don't have to, oops, try that again. 2/3. Let me just rewrite that. 8 and 1/3 minus 1 and 2/3. Okay, better. Yay, we have common denominators. So I should be able to get right to this. But if I only have one piece, how can I take two pieces away? I can't. So the borrowing or the regrouping means that I need to go to my whole number and chop one up. Let's do a visual of this. 1, 2, 3, 4, 5, 6, 7, 8. There's my 8 whole pizzas for the party. And 1/3. That's my 8 and 1/3. If I want to take away 2/3, I can't. I only have one piece. So I'm going to come chop up one of my pizzas. This is still a whole, but it's now been broken into 3 pieces. So what that looks like is 1, 2, 3, 4, 5, 6, 7 wholes and 4/3, right? 1, 2, 3, 4 thirds. And it feels kind of weird because it's a form that we don't normally use. So I'm going to come here and borrow one or regroup it. That got chopped up into 3 pieces. Why 3? Well, because my denominator was 3. If this was a 10, I would bring over 10. If this was a 75, I'd bring over 75. Whatever your denominator is how many pieces you're chopping it into. So I'm going to bring over 3/3 plus the 1/3 I already have means that now I have 4/3, which is what my picture shows. So if I have 4/3 minus 2/3, I have 2/3 left. 1, 2, and 2 left over. If I have 7 whole minus 1, I have 6 whole pizzas left. So after I do all of this, my answer is 6 2/3. It's a lot when you talk through it, but after you've done it a couple times, you go pretty quickly with it. All right, I'm going to do the same problem, but this time I'm going to switch to improper fractions. Let's see if I can write it correctly the first time. 8 1/3 minus 1 2/3. Yay. So to go to improper, we do the denominator times the whole number. So this would be 3 times 8 is 24, and then add on that piece. So 25 over 3, and I'll do the same thing down here. 3 times 1 is 3, plus 2 is 5. Now, if I did not have common denominators, I could still use this method. I would just have to switch so that I had common denominators probably from the step, right? I can do this. What happened up here? If we go back to the picture, this was our 8 1/3, right? All we did was split every single pizza into thirds. So instead of talking about whole uncut pizzas with a couple slices left over, I'm talking about the total number of slices that I have, right? 3, 6, 9, 12, 15, 18, 21, 24, 25. Hey, look, there it is. Okay, so now I can do 25 minus 5, that's 20. This is a perfectly acceptable answer. I know, it's improper. It makes everybody all twitchy. It's okay. It's in simplest form. You're allowed to leave it. Depending on the situation, you might choose to switch. You might choose to switch it to a mixed number. Let's say that we're talking about how many pizzas do I have? Or how many feet will this be? How many feet of whatever material that I have? There are situations where the mixed number makes more sense, right? I don't normally go to Home Depot and be like, hey, can you cut this board into 20/3 of a foot for me? Because they're going to look at you and be like, I have no idea what that is. I mean, they probably would, but they're going to look at you and be like, could you change that for me? Okay, so if I'm going to switch this, 20 divided by 3 is 6. 6 times 3 is 18, which means there's 2 left over. Hey, look, it's the same answer. It doesn't matter to me which method you use. Sometimes one method is better than the other because the numbers are friendlier or smaller or easier to work with. I do want to do one more similar to these where you have simply a whole number. So let's say we have the problem 7 minus 1.5. What would be the fraction here? Of course, our denominator would be 2. I have 0 halves. If you want to put that in there, if that placeholder helps you. If you were to do this with regrouping, you would end up with 6 2/2 minus 1 1/2. If you were to do this with the improper fractions, remember that, well, I can say it to you this way. Remember that 7 has a denominator of 1. That might help you. You might also just say, well, if I've got 7 pizzas and I cut them all in half, I'm going to have 14 halves minus the 3 halves, right? 2 times 1 is 3. Sorry, 2 times 1 is 2, plus 1 is 3, and then 14 minus 3. So it works the same way. I just wanted to point out that this is really a 0 over 2 here, or that you would do it as 7 over 1 if you did it as a whole number.